Here's the second example for finding x-intercepts. I have one example that is not factored, and I have one that is factored. Some people, when they work with rational functions, will start factoring as soon as they start working with it. They will just start factoring just to have it set up for what they need to look for later on. For y-intercept and x-intercept, I don't see a need to factor yet. We will have to factor later on when we start testing values and when we sketch the graph, and for finding vertical asymptotes to determine if in fact it is a vertical asymptote or a hole. We'll see that later on. It will be more convenient to have it in factored form. But for now, for finding y-intercepts and x-intercepts and domain, you can work with it like this, okay? There's no problem. So for this first function, we said when we want to find an x-intercept, that means y is equal to 0. So I will plug in a 0 for the value of f of x. And I will solve the numerator. I take my numerator, I equal it to 0, and now I solve this quadratic equation by using factoring. Always try factoring. If it doesn't factor, then you need to use quadratic formula. So 0 is equal to x plus 2, x minus 1. And now I solve for my x's. X equals negative 2, and I solve for this one, x equal 1. Remember in our previous example, I started off looking for domain, so I already knew who was in the party list and who was not invited. This time, I didn't do that. You could do that. If you don't do the domain, let's say like we just did now, I didn't look for the domain. Maybe I already have it from a previous step. But if you don't worry about it. All you have to do is once you find your x's, plug them into the numerator to check. Into the denominator, I'm sorry. Plug them into the denominator and make sure that these x values don't give you a 0 in the denominator. Okay, so let's do that. If x is equal to negative 2, then I have negative 2 squared, which is 4, positive 4. Positive 4 plus 2 times negative 2. 2 times negative 2 is negative 4. So far I have 4 plus negative 4, that's 0, and 0 minus 3, negative 3. So this x value does not give me a 0 in the denominator. That means he's good to go. I have my first x-intercept. Now let's check the other one. When x is equal to 1, if I plug that into the denominator, I get 1 squared, which is 1, plus 2 times 1, which is 2. So I have 1 plus 2 equal 3. And 3 minus 3 is 0. Uh-oh. That means this x value equal to 1 is not on the party list. And that also tells me that it is not part of the domain. So I end up with only one x-intercept for this function. Okay, this one here doesn't work. It produces a 0 in the denominator. Okay, if you had done the domain first, you would have already known that x equal 1 can't try to sneak in. Okay, for this function, everything is factored, and notice I have an x minus 1 factor here both in the numerator and the denominator. Some people will see this and automatically just cancel them out. I don't like to cancel them out because sometimes students will think because they canceled it out, it doesn't exist anymore. So to avoid that kind of confusion, just leave it there and work with it, okay? You could cancel it out, but you have to be very careful that you remember that they still exist, okay? So I prefer not to cancel them out. If I'm looking for x-intercepts, I equal my function to 0 and I plug in a 0 anywhere there is an x. Oh, I'm sorry, we're looking for x-intercepts. And I'm doing this like if I were looking for y-intercepts. So let me erase this part. Erase that. I made a mistake. If we're looking for the x-intercept, I equal this to 0 and I take my numerator and I solve for x. This is already factored, so all I have to do is x plus 4 equals 0, x equal to negative 4, and x minus 1 equals 0, x equal to 1. Again, I did not work with my domain first, but I can still check if these are valid x-intercepts. I take negative 4, I plug it into the denominator, and make sure I don't get a 0. So let's do that. Negative 4 minus 2, that's negative 6. And negative 4 minus 1, it's negative 5. Negative 6 times negative 5, that gives you 30. So this is good to go. One of my x-intercepts, it's going to be negative 4, 0. Let's check x equal to 1. Already I know if I plug in a 1 here, I get 1 minus 1 is 0. And 0 times anything is 0. So this value will make my denominator 0 or undefined value. So this is not an x-intercept. Okay? If we had looked for the domain here, if I had looked for the domain, I would take the denominator and I would make it equal to 0. I would factor and I would solve, and this would give me x equal to negative 3, x equal to 1. I would know beforehand what two values are not in the party list. So I would know x can't be 1 and x cannot be negative 3. And then when I looked for my x-intercept, as soon as I saw x equal to 1 come up, that would ring an alarm. You know, it would ring an alarm. Hey, you can't come in. Don't try to sneak in. Okay? So I would know this is not an x-intercept. Same thing for this one. If I had looked for the domain first, I would have taken the denominator and I would have equaled that to 0. And I would have solved for my x's. This would be x equal to 2 and x equal to 1. And then when I go ahead and look for the x-intercepts, as soon as x equal to 1 shows up, that rings a bell. You can't come in. I had already said that you were not on the party list, so you can't come in. So automatically I would have known that. But when we don't look for domain, you just go ahead and do this procedure and then check your x's in the denominator and make sure you don't get a 0. Okay, so any of these two ways are good to go. I hope these two examples have made it a little bit clearer. Make sure you study, go over them, try these on your own, and see if you get the same answer. Okay, next video we'll talk about, I said we were going to talk about holes. First we're going to talk about vertical asymptotes, and then we'll talk about holes. So my next video is vertical asymptotes.